So you found the skeleton. How would you tell it's a dinosaur? You personally, how would you decide?
Well, interesting question. I don't know. I'd have to do some research on that.
Alright guys, we are live. Currently, the rest of the panel is on mute because they can't figure out how to get quiet for the intro. But that's okay. They're unmuted now. So we are here for the after show for Dan versus Sal, which was on Modern Day Debate last night. It should be linked in the description. If it's not, it will be later because I don't know. I'm lazy and forgetful. Just don't have hair like me, see? Fair enough. Yeah, Dan, you got a pretty good head of hair going there. We got so. All right, so let's see. We got Phil Ko, Dakota Mooring, and Clifford Reynolds, and Monk Mayfair in the chat right now. We got a few other people. Hey, Dakota. So let's go around and introduce everyone. You guys know who I am if you're on the channel. Okay. T Lane, say hello, introduce yourself. All right. Dan. Oh, we'll go Colton. I was gonna go clockwise, but no. Go Colton, go. All right, go ahead. You're actually a professional at the thing that we just dabble in. Okay. Wait, people are saying that they can't hear you. No, hold on. Let me see what's going on. I can fix this. Okay, I think I figured it out. All right.
All my stuff is on.
Okay, I figured it out. So
can they hear us?
So what we're gonna do is I'm later in post gonna cut out a few minutes of that because I screwed up. Sorry about that, guys.
Oh, is this not broadcasting live, or are you gonna put the uploaded version with an edit?
It's broadcasting live, but I can cut things out with the YouTube editor.
That makes sense.
The YouTube editor.
TV.
Yeah, the YouTube
let's
editor
try that again,
sucks,
shall we?
Yeah. So Dan, go ahead and introduce yourself. I'm sorry.
All right. Hi, I'm Dan. I was in the debate last night. I'm a biologist. I'm an evolutionary biologist, and I'm a biology professor. So teaching biology to college students is what I do. And on the side, I enjoy spending time debating creationists on the internet. Doing it on YouTube is new, but the overall exercise is not new. You can find me on the internet under the name DarwinZDF42 in various places, but a lot of what you find will not be related to biology or creationism. Thank you all for being here.
Yeah. So, as I said, this is for the after show for the debate, and I gotta say, one, Sal, if you're listening or you do listen, which I don't know, or if you come in, I would really like to have you in here. However, I really think that the debate went heavily in Dan's favor, mostly because I feel like Sal failed to even attempt to address most of the points that you made. Some of which,
yeah, if I can make a an attempt, because Sal, I'm sure you're probably listening, and I think you seem, even though I'm not too pleased with how you come off in text, I get it. It's Reddit. There's no reason to take it that seriously. You seem like a nice enough guy. Next time you do a debate like this, maybe in your next one that you have with Dan, spend your 3-minute rebuttal actually talking about his statements, because I don't feel like you addressed much other than his definition of fitness, and it really kind of felt like Dan had more power than you. That's all I'm going to say.
The fitness definition the fitness definition actually confuses me because it seems like what he's arguing when he changes to medical or whatever fitness definition we want to use that isn't actually the definition of fitness in evolutionary biology, that it's like, well, the evolution of the human species might result in something that does not accord with my personal preferences for how it would evolve. Therefore, evolution is wrong.
Yeah, it kind of felt like a sort of, sure, maybe that's your definition of fitness, but I really don't see how someone could see a one generation having an average IQ of 80 and another having an average IQ of 75 and thinking that that's an improvement. And it really seems to be based on this idea of an objective ladder of evolution instead of a relative standard of what works for the following generations.
Yeah.
Maybe I'm wrong on that, but
what do you think about that, Dan?
Yeah, I get very frustrated with the debate over the meaning of fitness. Evolutionary fitness has a very particular definition because evolution doesn't care at the end of the day how smart you are, how fast you are, how big you are, how efficient your hemoglobin is. All that stuff is upstream of being able to reproduce. And if you can reproduce, your alleles will be represented in the next generation. And if you can't, they won't be.
Yeah.
And like, that's what it boils down to. And you could pick that apart and get into, little components of that, because things like, how, problem solving ability or something, that's obviously a component of being able to survive and reproduce, but that's not the ultimate measure. And there's lots of examples where you can, something, you hear the term devolution thrown around a lot, or reverse evolution. And it's exactly what Colton said, that it implies this ladder-like approach rather than a branching approach where it's about relative fitness. There's some absolute standard that you're measuring up against, and that just doesn't exist in the context of evolutionary theory.
Well, one of the things that always strikes me is, like, you look around, right, and you can see examples of organisms diversifying into much more complex areas and also into much simpler areas. Like, so you take a look at, say, a tapeworm is basically some hooks and some gonads wrapped in skin.
Yeah.
That's basically it. They don't have a digestive system. They don't have a respiratory system. They barely have a nervous system. But it's a very successful organism. There's a lot of tapeworms out there. Trust me. There's a lot of them. So does that mean that evolution failed them? Well, no, because there's plenty of them. And so they're going to keep on going, being basically a set of hooks and gonads wrapped in skin.
That was kind of my impression of Sal's whole argument with the he wants to focus on the medical or the intuitive or the engineering definition of fitness, which seems to assume that there's like some goal where humans need to reach a certain IQ, or we need to reach a certain number of diseases, and like we need to fall below that baseline or something. And it's like, the fact of the matter is, whether or not my genes reproduce does not matter about, my mile time, when I run, when I'm working out, unless that mile time is specifically part of what allows me to reproduce, if that makes any sense.
And actually,
it doesn't matter if I can bench 350 pounds or run 6 minutes, or a mile in 6 minutes, if neither of those affect my ability to make a girl attracted to me.
Yes.
And the same thing applies to anything else.
A sterile Superman is not going to be some major effect on evolution. It's just, okay. Yeah. It's great that you meet. So actually, Michael Apple asked how Sal defined fitness, and he didn't really give a great definition. It seemed to just come down to, like, would an engineer or a doctor say, yeah, you're doing well?
And
it was almost precision in terms of like the structural biology. It was how like various molecular features of a cell are tightly constrained in terms of like their physical structure, like in terms of the job they do. And the example he used a couple times was like the width of an ion channel has to be very precise for the ion that's going to go through it. And if the diameter of that channel is a little bit off, it doesn't work correctly. So his definition was kind of based on, at the molecular level, kind of deviation from these very tightly constrained, precise structures. And then at the individual level, very much based on like health and intelligence, really. There was that long example with Einstein and Dumb and Dumber, That was just straight up.
You
like,
know, yeah, that was
the
kind of
was the measure.
painful. That was kind of painful. And the thing that I was thinking the whole time is like, I was born with a mutation. At least I think it's a mutation. I haven't got my genetic sequence, but basically, I'm missing an adult tooth, one of my premolars. It never came in. So I'm at 21 years old. I still have one baby tooth. Now, would this be a problem if I was in an anarcho-primitive society? Yeah, I would probably crack that baby tooth and I would be completely screwed with an infection that would hurt my brain and kill me. But I'm sitting in the 21st century where all I have to do now if that tooth cracks is go to a dentist, get it removed, get a fake put in, and my genes go along fine. And that's kind of what fitness is. It's not a bad mutation if my environment doesn't have a problem with it. As far as I'm able to understand, I'm assuming I'm being coherent here.
And this is like the problem with Sanford's argument, because Sanford proposes that fitness is constant. So you have a specific genotype. I don't really like to talk about it in terms of mutations, but that's how he talks about it. But it implies this degeneration from an optimal state. But if you just talk about different genotypes, Sanford talks about fitness being constant for a particular genotype. And if you have a new mutation, then that mutation has a very particular fitness level. And that doesn't happen in the real world. The tooth example is great. The tuskless example with elephants I really like because I don't want elephants to go extinct. In the absence of human hunting, being tuskless is really bad. But in the presence of human hunting, being tuskless is awesome. And those things are not like this stuff is context dependent. You can't just apply like a fixed value.
It almost seems like they've got this mental idea in their head. This is purely speculation on my part, but when I was a young Earth creationist, this is kind of how I thought, where it's like you need to consider your ideal fitness being, what would the world have been like? What would have been a good environment pre-fall, instead of like, what's a good environment 21st century where humans are despicable and we're evil and we have guns and we shoot literally anything that moves that doesn't look like us. It really does seem like creationists come from a mindset of, well, maybe they're fine now in a fallen world without tusks, but in a perfect world that would be really bad for them, and we need to be basing it on the standard of the pre-fall perfect creation and not, what the fallen sick world is now. Maybe that's kind of like a mental block. And I'm only suggesting that because I want to help communicate to these people, because I like standing, I like raw mat, as ignorant as I think they can be. They're good people. And I wanna make sure that our ideas are coming across clear to them.
Yeah. And I like Dan said though, assuming that starting point with this hypothetical perfect genome is assuming your conclusion at the outset. You don't
absolutely
get to do that. You have to if you want to show that there was once a perfect genome, you have to show that. You don't get to start with that assumption.
And I was thinking
point me to
about
a perfect
that,
genome, or point me to something that is objectively so much better that it would be hard to deny that it couldn't be, that there are degrading genomes that we have now when this one is so much better.
I mean, Dan, maybe you can clear this up for me. And I'm sorry because I'm a bit buzzed, but like, with like Neanderthal genomes, like at least a mitochondrial genome, I don't know anything if we have the nuclear genome or not. But even with as fragmentary as it is with the remains, we can still reconstruct what it would have been, right?
Oh, I believe we have a full Neanderthal genome, nuclear genome, yeah.
Would it, in a 6,000 year time frame, be that difficult to at least reconstruct what a perfect, like pre-fall human genome would have looked like if we've only got 4 to 6,000 years of mutations to work with? Would it not be that difficult of a task?
I mean, you can do coalescence analysis for the human genome and figure out like what the common ancestors for every part of it is. But it doesn't get you to 6,000 years ago. It gets you to at least 200,000 years ago.
Yeah, I'd figure if you can like, with their whole argument of like the unrooted tree where you've got like the 3 mitochondrial haplogroups, even though there's 4, you'd think that if you can see those
Genome.
patterns in a young Earth creationist time frame, years, it shouldn't be that hard to, at the very least, reconstruct what Noah would have looked like, or his sons. I mean, we don't really have that much time to work with to get mutational diversity.
Absolutely. If you do the reconstruction, and you work backwards, assuming a young Earth time frame, then the Y chromosome most recent common ancestor is Noah.
Yeah. Which
Didn't Jeanson admit, even in his Y chromosome study as of 2019 or maybe 2020, I don't remember which year it came out, but it was one of the two, that he was still using pedigree studies instead of like 3-year?
Yes. By the way, hey, welcome.
Hey.
Welcome, Dakota.
Quick point. I want to just go back to real quick with fitness that really gets at the crux of the issue, though, is that where was I going with this? It's that once you start allowing fitness as a creationist, once you allow fitness, and this is specifically for the context of this debate, once you allow fitness to be reproductive output, you're decoupling it from things like complexity. And you can then have what creationists would characterize as, genomic degeneration or loss of whatever, and an increase in fitness. And there's lots of examples of this with like all the organisms that live in caves that don't have eyes, like that kind of thing. But then the problem is, in order to invoke genetic entropy, you then need to invoke a change in environment. And now you're saying, okay, all these things accumulate and they may be helpful in environment A, but they're bad in environment B. And then when the environment changes, now you have extinction. And the problem with that argument isn't that it's wrong. That's actually a reasonable description of what happens sometimes in periods of like rapid environmental change, or like the introduction of an invasive species. The problem with that argument is it is not Sanford's argument. And making that argument as a creationist is implicitly acknowledging that Sanford's argument, as he wrote it in Genetic Entropy, is wrong.
Yeah.
So if you're arguing about Sanford, you're not allowed to make that argument.
Yeah, and actually, that's a point that you brought up.
Yeah, I was kind of. Oh, go ahead.
And that was a point that you actually brought up in the debate about, like, how come we have all of these organisms that are either more susceptible to these supposed effects or are on a similar level at a per generation level, but have much faster generation times, and we're not seeing this error catastrophe happen? Like, why are there still mice? Why are there still bacteria?
Can I actually ask a question to Dan here? What do you think about the argument that Robert Carter made on creation.com about mice supposedly actually having evidence of error catastrophe in their genomes, or at least genetic entropy? Maybe they're not fully at the point of being extinct yet, but they're getting there.
I don't think he was able to show any decline in fitness. And I think kind of in the same way he does in the H1N paper that we didn't get to discuss yesterday, I think they not just Dr. Carter, but a lot of people repeatedly mistake the occurrence of mutations in a genome for the occurrence of error catastrophe or genetic entropy. And those are not the same thing. Mutations can build up without having any kind of fitness cost.
Yeah, because I noticed in that, like, that creation.com article, I won't even give it the credit of calling it a paper, but that article where they were like talking about, well, what about mice? What about bacteria? And at least with mice, Carter was like, hey, they have a lot of chromosomal diversity in terms of like their chromosome count, and that's evidence for genetic entropy. And I really think that drives back at your point 4 in your. Oh yeah, he did that. Carter actually said, because there's a diversity in the genomes of mice, of species of mice across the board, that means they are experiencing genetic entropy, even though he didn't document any fitness decline in their respective populations. And I think that really is driving home the key point that Dan brought up on like his point 4, I think it was on his slide, that genetic entropy inherently assumes there was a perfect genome to start with.
Yeah.
And that if you see diversity of a genome, that can only mean that bad things have happened. It's literally asking, to define itself into being correct.
It's a begging
And
the
the
question
fact that
fallacy. Yeah.
The fact that I have seen creationists like Paul Price, when they say, hey, when someone points out to him, hey, don't you think it's a little unfair for you to be saying, no, if you don't let me define the terms, you're an anti-science, idiot. And they'll respond to that with, yeah, if you don't let me define the terms, you're just being anti-science. And it's astounding to me that this is the mentality that they can carry and they can actually think that's justified. Instead of, like backing yourself up with data or something, you can just keep reasserting your conclusion as if your assertion plus the volume of your assertion is itself the evidence.
So if I can throw this to the room, because having participated in the debate but not having watched the debate, I don't have a feel for how things actually came off to viewers, because I don't have, as I think some of you probably know, time is different when you're actually participating in it, and it ebbs and flows differently. So what was the general feeling about the flow, and in terms of being able to cover a reasonable breadth of arguments, and whether we were actually able to stick on a topic long enough to get a reasonable conclusion out of it before having to move on? What did everyone kind of think?
I feel like Sal was a little bit rushed on his part. I think you did actually well on explaining your point, and from what I saw on the subreddit, that seems to be the consensus view, that you got your point across pretty clearly. I think Sal could have definitely made himself more succinct, but other than that, you guys seem to have a pretty decent flow, at least in my opinion.
Okay, let's get RJ in, and because he's just joining us now.
Hey, RJ, welcome.
Hey. So, what do you think about how the flow went? If you're actually really here, I think RJ might only be here in spirit.
Yeah, I put my pause on it at I'm up to 36 minutes in, which is still in Sal's view. I've been going through his quotes and his sources that he's drawing on and what topics he was bringing up. He's trying to wave Dan Grauer. He's going off on junk DNA. He's trawling a bunch of stuff. From his own presentation point of view, he seems to be wandering a lot. I'll eventually go through all the remainder to see all the back and forth on that to find out if he actually is just going into deer in the headlight mode, but it's not looking good.
Oh, yeah. If I may, Dan's presentation flowed perfectly. It was great. It felt like a classroom presentation that was really informative.
Almost like he does this for a living.
Yeah, I actually did, Dan. I felt like I was in a classroom with you with that. It had the same vibe.
I've been doing this exact thing way more than I ever want to for class. I've recorded so many lectures over the last few months, and I really miss doing it in person.
Yeah. What do you think?
If I had actually taken genetics, I would have gone to your class.
Let's get something from Dakota. He's been sitting here very politely and very quietly.
Yeah.
Come on, what do you got for us?
I just want to see if Dan will get his spiel on the H1N1 paper, because I've heard it.
God, yes.
I know YouTube hasn't heard it, and it's truly something. So
I please bring it up in the second time.
It's his most favorite bad paper ever.
It is my favorite bad paper, and here's why I tried to bring the discussion to the H1N paper. So the point of that seeming digression was that it is the situation where if you ask a creationist who is knowledgeable on the genetic side of things, say, okay, give me an example in nature of something that experienced genetic entropy, 99 times out of 100, you're going to get Carter and Sanford, 2012, A New Look at an Old Virus. I forget the rest of the title. And that paper is looking at H1N1 in the 20th century. It spans 1918 to 2009 is what they say the data range is. And the argument in the paper is that this terrible strain of influenza that tore around the world in 1918 was extremely high fitness in 1918, killed between 50 and 100 million people. And then over the rest of the 20th century, its virulence dropped off precipitously. It accumulated a bunch of mutations, and it went extinct in 2009. You know what? Hang on. I have slides. If you don't want, if you want to just give me a second,
Hey,
I can.
Screen share it up.
Give me a second, because I was prepared for this, and then we didn't get to do it. Now, it was okay because this was the part of the debate where, if I remember, it was okay, viruses don't count because Sal wanted to talk about eukaryotes. So I said, okay, what about mice? And it led into that thing. So it ended up working out okay anyway. But I really wanted to talk about H1N1 and this paper. So let me just pull this up for a second, because this is so I didn't mention this last night, but like my graduate school work was literally on the topic of this paper. It's viral mutation accumulation and fitness, and in particular, how that affects codon bias. Like, it is this specific topic. There's 12 people in the world that care about viral codon bias, and I am one of them. Let me just find the appropriate spot, and I'll give you a screen share here, because this is the example. And I wouldn't harp on this paper so much because it's not worth it. It's just not good. But this is the example. When you ask for an example of genetic entropy, this is what you get.
Yeah.
So
as you're saying this,
to...
I'm hearing Saying for Truth saying H1N1 went from a global epidemic to an extinction event in whatever many years, because he has that.
Can I ask something while you bring up the screen share?
Yeah, thing? I've never used this, by the way, for anyone watching. I've never used this platform before, so this is just going to take me a second.
There should be a button down at the bottom middle of the window.
Yeah, I got it. Just a second here.
My question essentially is: didn't the paper, even though it claimed H1N1 went extinct in 2009, didn't it also admit that at least part of that 2009 strain recombined with like a pig version of it, and then became like a mutant to hybrid?
Yes,
okay.
That was the 2009 pandemic strain. I'm going to get to it. Don't worry. This is.
Thank you, Dad.
So can you see the PowerPoint slide?
All right, I've got it. Everyone can see it now.
Great. Okay.
Hell yeah.
So I'm not gonna put the. Well, let me just.
I can't.
Yeah, it'll mess with my screen if I put it into full screen. So we're just gonna go with it this way.
You should be able to.
Here, I can get rid of. Here's what I can do. Here, we can get rid of that. That cleans it up a little bit. Okay. So, that's the wrong slide. No. There we go. Okay. So this was 2012. A new look
we
at
have
virus,
screen.
patterns of mutation accumulation. Blah blah blah. The idea here is that they didn't say this in the paper. They didn't use the phrase genetic entropy in the paper, but this is what they meant. That the 1918 pandemic strain of influenza experienced genetic entropy and went extinct in 2009. And they did not do a good job supporting this assertion.
They weren't publishing it in a regular creationist journal, I think.
This was a legit paper in a legit journal. I forget the specific journal.
It was like theoretical
theoretical and computational biology,
like
maybe. Yeah,
Journal of Mathematical Biology or
So here's the first problem.
Theoretical biology and medical modeling.
These claims, as we've been saying, they rest on evolutionary fitness, being able to reproduce. And that's really easy to measure with viruses. It's really easy to measure fitness with viruses. So I was really curious because they didn't actually say anything about measuring the rate of reproduction in the paper. So I emailed Dr. Carter and asked him. And I had a bunch of questions, but I said, and finally, did you compare metrics such as burst size, which is how many viruses bust out of a cell, burst time, which is how long it takes from when the virus goes in to when it goes out, attachment rate, how efficiently does the virus attach to the cell, adsorption rate, how fast does it get in, and then doubling time just takes all this stuff together and calculates the curve of how fast the population grows. And you can measure all that stuff directly with viruses. The math is pretty straightforward. Did you do any of those calculations for the different genotypes in the H1N1 data set? And we have sequence data from the 1918 pandemic strain. And his answer was no, we did not compute any growth metrics. Our work was done on computer only. So they used proxies for fitness instead of direct measures, which is not necessarily invalid. Sometimes you can't measure stuff directly. That's fine. But the way they measured fitness was terrible. They used two measures for fitness. It was codon bias and virulence, so how sick the virus made people.
Why would
and they correlated both of those things with mutation accumulation.
Okay, hold on, because this is something that bugs me a little bit. What in the world does virulence have to do with how good a virus is at making more viruses?
Can I try to answer that?
Well, just hold it for 1 second, because I think
Okay.
that's the next slide. Yeah, that's
Okay,
the next
good.
slide.
Because I'm just like, why would this be a measure of fitness?
Right, it's not a good measure of fitness. So, but to dispense with codon bias first,
Sorry.
influenza is an RNA virus. Its genome is RNA rather than DNA, which means it mutates really fast. And to give everybody a little bit of a primer on this, within the DNA, you have your DNA sequence of A's, T's, C's, and G's, and when you're making a protein, you read those bases 3 at a time in order to convert to an amino acid, and the amino acids are the subunits for the proteins in your body. So each of those 3-letter words is called a codon. Now, there are 64 codons, but there's only 20 amino acids, so there's redundancy in the code. So, for example, CCC codes for proline, so does CCA, CCT, and CCG. Those are called synonymous codons. When you use those unequally, you use like CCA 90% of the time and barely use the other 3, that's called codon bias. And every organism has some kind of codon bias, but it varies from thing to thing. Now, you'd expect a virus to want to match the biases of its host because it's dependent on its host for gene expression. But for RNA viruses, what we find is they mutate super fast and they don't match their host. Their codon bias is basically random with, if you're comparing it to their host codon preferences. And here's a figure from a paper that shows this. This is looking at plant RNA viruses. And the different colors of the 2 different genes in these viral genomes. And you can see that there's no correlation here.
I took a
represents
statistics
codon.
class. I took a statistics class. Hate to be that guy.
Hey, look
but
at
wow,
who
that
the
is
author
no
of that
correlation.
is.
There's no correlation there. And the title of this paper is so when you're selecting for codon bias to match your host, that's called translational selection. And this paper is translational selection is insufficient to explain codon bias in various viruses. And there's just no match.
Familiar.
Now the other problem with this argument that the loss of codon specificity in influenza is a loss of fitness is that, and I apologize, this is probably boring for like everybody, so I'm going to.
No, I'm actually pretty interested. So
I asked if
And I'm half coherent.
no.
Well, if anyone in the chat is bored, just tell me and we can talk about other things. So one thing that they miss here is that the codon changes that they document. It's one of the figures in that paper actually shows the trajectory for the 4 types of codons, based on what base they end on. The changes they document are actually adaptive in humans because humans, our immune system recognizes C followed by G. That's like a thing we recognize as foreign to us. So our immune system flips out when we see C followed by G. It's called a CpG or a CG dinucleotide. And the changes that we see in this influenza strain actually are to reduce the amount of CpG in the genome, which makes it elicit a less severe immune response. So that's actually adaptive. And that signal is going to be a lot stronger than selection for translational efficiency because it's an RNA virus and they just don't care about translational efficiency. So that's the first problem. But that's not the big problem. The big problem is the virulence side of things.
yeah, that's the minute you said that, I was like, that doesn't make any sense at all.
No.
Can I try to give like my understanding of this and see how well it compares to what you have on the slide here?
By the way, the chat is not finding this boring. They have
Okay, good.
Okay.
So the way I understand it is like, let's say you've got person A and person B, and both of them get a strain of influenza. Now, person A has a strain that is very, very good at making viral copies, and so many more of his cells get infected very quickly, which means he has much stronger symptoms thanks to his much more panicked immune reaction. And person B has a weaker strain of influenza, and so he's getting less strong symptoms. Now, person A literally cannot leave his bathroom. He is stuck glued to the toilet, throwing up and having the worst symptoms of his life. Person B kind of feels bad, but he's good enough to be able to drive, to go fill his gas tank, so he touches the gas pump, and he touches the PIN code thing for his credit card, and he goes
spreading the virus.
He goes into the pharmacy, he touches different flu remedies, but he decides, this one's too pricey, and he puts that back, and he gets the generic, and so now he's looking at the virus on the name brand, and he touches the cash register terminal, and he goes home. Isn't the weaker virus that is making less viral copies per cell having a much greater chance to spread to the total human population than the guy who literally, even though each individual virus is making more copies, he can't leave his bathroom.
Yeah.
And so the weaker virus is going to spread a hell of a lot more quickly and have a much better chance at spreading its genome and having a much higher evolutionary fitness than the strong quote-unquote virus that literally incapacitates its host and can't make him leave his house. Right?
Yeah. So that's a perfect description of what happens with high virulence versus low virulence.
Oh, hey, we have Sal in here. I am going to ask.
Wonderful.
I'm going to add Sal, but that's a fair few people. So if we could have one person, yeah, actually, we have to have one person drop out.
Bye bye. Have fun.
Oh,
All right.
bye-bye.
Bye to you
See you,
later.
Dakota. I'm going to go use the bathroom real quick.
Well, I can go.
Okay, well, Sal, sorry it took a little bit to get you
Hey,
in.
Sal.
I have a 6-person maximum in the room, so I had to drop someone to let you get in here. But how are you?
Hi.
Here, I'll cancel the screen. We can go back to the screen share later if people want.
Okay,
but
yeah.
We'll go back to influenza later if people want.
Oh, I'm sorry. I didn't. I just got a little link, and Dan was kind enough to invite me to talk or
Oh,
join.
yeah.
And I didn't know.
Yeah,
I thought
welcome.
this is. So I had no idea what I was in, but it was very
Well,
kind
this
of
is-
him to invite me. So
So this
I
is
don't know what this is all about. So
you,
forgive me if I'm clueless like I usually am.
So we're having a after show for the debate on a lot of the evolution and creation debates that end up happening on Modern Day Debate. My channel will then host a little after show where people can come and talk, and it's not formal. And to be fair, we do sometimes ask difficult questions, but we're at least always friendly. Well, except for
We also
that one
scheduled
time.
the day after because Dan has a toddler that he has to take care of, so we couldn't make him stay up too late.
Yeah, we couldn't do the one until like 1 a.m. last night. That wasn't going to work.
So yeah, and my rule is always both debaters or all debaters, if there's more than two, get the join link so that they can come in. And so I guess I'll just ask the question I usually start these with. So what did you think of the debate? How do you think you did? How do you think Dan did?
Well, I think Dan did excellent. I think he beat me up pretty good, and so although I did get very good feedback from both sides, and so I'm looking forward to the next round.
And so
Yeah.
there was actually a question about that.
I'm glad to see you more concerned with your actual accuracy than quote unquote winning. That's always nice to see from people.
Yeah, I actually respect people a lot when they say that. I think maybe I didn't win that debate because it's like, all right, that's like, don't say it if you think you actually won, but like, yeah, I think there were some missteps on your side. I think that a lot of the times it seemed like the things that you were addressing weren't the points that Dan really was bringing up. Do you think that's fair, or am I?
No, I didn't address his points because I didn't think they were relevant.
Okay.
But you interpreted it a different way. I don't. Since we're having a second debate, maybe I
You
don't
can
want to
save
give
that
it
for
all
next
away.
time,
Yeah, we don't want to. Yeah, we don't want to.
I'm so surprised, man. Have fun. It's supposed to be fun. It's not like don't act like this is something that your whole career is based on, because it's not. I mean, it's just a fun little back and forth.
No, we're good. Well,
Yeah, no,
I wanted.
have-
Well, first off,
YouTube.
I wanted to, I wanted to at least give Dan the courtesy because it was so kind of him to invite me. I wanted to at least show up, but if you wanted to talk about other things, because we want to build up the drama for Wednesday. This
There
good.
will be
This
plenty
is good.
of drama.
This is great advertisement for my websites and my channels.
Absolutely. Actually,
I've gotten more exposure because of Dan than anyone else, so I own a lot. So
and actually,
nice.
Sal, if you want to send, you can either send stuff to me. Have a long email, I can get it for you, or you can send it to Dan, and I can put links to your website or anything in the description for this. So yeah, if you want to have your links in this description, so that way anyone who comes in will get that.
I'll give you my website that I'm building out, and I know Dan is.
Actually, you can just drop it in the side chat if you want. I can grab that.
Yep. And nice to see you, Corporal Anon. On different sides, but no hate.
Oh no, we often talk about the fact that while there's a lot of people that we disagree with and interact with in kind of an adversarial manner, a lot of them on a personal level we actually like. Like for instance, a lot of times we'll talk about the disagreements we might have with, say, like Standing for Truth or something. But I genuinely think Standing for Truth's a nice guy, and like not that long ago, he liked one of the elements I used in my video, so I just sent him the file. I was like, here you go, you can use it. So
yeah, frankly, on a more personal level, I'm more liable to give someone hairstyling tips than I am to tell them why they're wrong. That's just me. Like on a one-to-one basis, that's all I really care about, making sure that whoever I'm talking to feels good about themselves.
So I didn't want to totally disrupt the flow here, and I'm sorry I showed up late. I actually finished out a Bible study.
Oh, it's okay.
Oh, hey,
Yeah,
no
you're good.
worries.
This is come and go. So Sal, I want to thank you for agreeing to do this again. I'm super excited for next Wednesday at 8. I don't know, have we announced it yet? Wednesday at 8 p.m. We're going to do it again. It's going to be fun. And Erica will be there this time. So we'll have 4 people.
Yeah, so she says. We'll have to take her word.
She might get lost in the woods again.
I wanted to cover for her and say she's rescuing all these primates out there in the middle of Africa, and she was just delayed getting back to us.
Well, look, it's not tipping my hand, I don't think, to say like in round 2, I want to just go back to the stuff I raised at the very beginning that we didn't really get a chance to address. I want to talk about the math. I want to talk about the fitness distributions. I don't think it's going to be a surprise. I'm not planning to surprise you with it. You probably could guess exactly what I want to talk about in round 2. So I'm not worried about tipping my hand here.
Okay. Well, I mean, I'm actually a little bit physically exhausted, and again, I do apologize for being totally clueless. I had no idea that this is. See, some after shows are a little bit different than others.
Sal, there is no reason to apologize. You are 100% okay as far as I'm concerned.
Oh, thank you. So, just tell me how I could be of service to the show.
I mean, we really are just here talking about what we thought about the debate, and there is actually a question that I was wanting to ask you during the debate, but I didn't really get the chance to because I was multitasking throughout the entire day.
Well, go ahead. I'll answer it. I promise. I'll try to give you an answer since you're the host.
Okay. Well, thank you. So the question that I had was, you, when talking about fitness, went into things. I believe your terms were medical and engineering. But why is that an important measure when, according to at least standard evolutionary theory, fitness is in fact reproductive success, and so we have animals that become simpler, and if it helps them reproduce, then that's fine. So that doesn't seem like it contradicts anything in evolution to say, organisms can decrease in this kind of, they're getting dumber or weaker or smaller, but that's okay, that's not a problem. So why did you use that definition?
Because I'm trying to decouple well, first off, this is from, I'll reference the paper, Santa Fe Bulletin, winter 2003. Richard Lewontin talked about why fitness, the idea, he specifically said it's not entirely clear what fitness is, and Darwin's sense of fit has been bypassed. So that's Santa Fe. Let me just type it in, just to give the reference. I'll put it in the chat.
Okay.
Santa Fe winter 2003.
He's still around. Have you contacted him for his current view?
No, but I'll tell you how this. That's a good question. So Santa Fe Bulletin, winter 2003. That paper is so influential that an evolutionary biologist by the name of Stanley Salty, I think he's at Stony Brook or emeritus now. He read that essay. He said he was having his doubts about Darwinian evolution. He read the essay by Lewontin. He said that was the end for him. He signed the Discovery Institute scientist at Descent, even though he doesn't. Yeah.
Do you know what the title of that is, other than just Santa Fe Winter 2003, so I can try to get it for RJ and Dan to look at?
Yeah, why don't
I'm just trying to be the source methods guy.
Is there a way I can post? that's the best title I have. I have a copy of it because it's really publicly available. It's
Do you
actually
want my email to just send me the paper and then I can send it to them?
yeah, we
Or,
can do
like-
that. I'm going to post it on my website sometime, but I want to make sure you get it so you all can study it.
I'll throw my my email in the private chat of this thing, and you can just send it.
Yeah.
And I'll share it with relevant people. I have nothing to comment. This is completely outside of my field.
And I wanted to continue with your. So I didn't completely answer your question, except that got me thinking when Lewontin said that. And then the reason I found it was Stanley Salty. I mean, for an evolutionary biologist assigned to Discovery Institute, Descent from Darwin, even though he doesn't accept intelligent design, just to be associated with the Discovery Institute was a big step. And
Right, because you feel like even then this paper was influential enough to make him realize, even if I disagree with point A, point B is still that bad that I can't sign on to it anymore.
So the thing that happened was I said, well, that really stood out to me. And Stanley Salty had a very interesting essay on Darwinian evolution. And I said, I've got to find out what Lewontin had to say because I really respect what Lewontin had to say. And then this topic was revisited back in January because of John Sanford and Bill Basner's paper on Fisher's fundamental theorem of natural selection. We got called by editors because their paper actually broke so many records for downloads, and it caught the editor's attention. So they wanted some follow-on work, and I got recruited to work on that. And so I mean, I had to spool up, and then I said, "Hey, John, hey, Bill, look at what Lewontin said." And by the way, there was a later paper by Grodwall, and I'll include that in the email. And it was just savage. I'm just like, I don't know that a creationist could have written anything better. And so we were going over the concept. So I'm going to be posting on my website stuff about kind of a simplified version of Fisher's fundamental theorem, and then also things from Joe Felsenstein's book, Evolutionary Genetics, that talk about why fitness, there are pathological cases that Patrick Moran found where fitness will not maximize as a matter of principle. And I said, that was interesting. And then just in the process, so your question is, why did I go into that? I began to see that this is a very... These S coefficients which define fitness, they're very fluid. And there was something very unsatisfying. And then in the process of examining this, I said, well, engineers don't describe things in terms of reproductive success. An airplane is fit to fly. A submarine is fit to go undersea. A car is fit to drive on the ground. And then I looked back at some of Darwin's stuff, and yeah, he was kind of in between. He would kind of describe things like machines in terms of engineering. And I skipped an example where Darwin was describing the honeycomb and how well it is designed. I said, yeah, you see, he was describing it in terms of mathematical optimization. I said, that's the way to describe things. And then I showed briefly a clip of William Bialek and how they're describing the optimization of various systems. So, one, I felt this was a more satisfying definition. And then when evolutionary biologists are describing sickle cell anemia as a beneficial trait in terms of reproductive success in a malaria type environment like in Africa, it's like, well, yeah, it is reproductively successful, but there's something that doesn't quite connect with kind of the medical definition.
Can I ask you
Sure.
something?
Yeah, go ahead.
I guess my question is, like, at least in evolutionary biology, our standard of what is quote unquote optimal is being able to reproductively succeed without having some sort of negative fitness cost. What exactly is the equivalent standard with the medical fitness? And if there is one and I'm not aware of it, forgive my ignorance. I genuinely don't know if there is.
I don't think it's been codified, for one, because like when someone's sick, That's our standard. You know, if someone
You can tell
now, there
well,
are
right? It's like
certain
intuitive.
yeah, but there are certain things, and this was what was really great about Bialec's book. There are principles in physics where you can adjust something to be just right, just like optics. I mean, you know, when you get, you know, when someone gives them corrective lenses, it's like, well, there is a certain, you're doing something where you think this is the correct thing to do, and you can actually describe this in terms of geometric optics.
So like, if I was to think of, instead of like, let's say I have poor eyesight and somebody gives me a pair of glasses, maybe there's a certain level of tuning which will allow me to read enough to where I won't starve to death because I can't read the McDonald's menu, but it's not tuned enough to where I could actually learn something from a really detailed book with fine print. And that level of tuning, which would actually allow for me to read something so fine and detailed and precise, that would kind of be the medical definition as opposed to the Darwinian definition, which is whatever allows me to not starve to death. I'm sorry if that doesn't make sense.
Well, no, that was pretty close. So,
okay.
So when you go to the optometrist or ophthalmologist, they have all their instruments, and it always amazed me when they're just fiddling with the instruments, and they say, and they're just looking at through their instruments, and they adjust it, and they say, "Can you see better?" And so, like, how did you know that was where it was? They said, "Yeah, you know, they do something with their instruments that's based on physics, geometric optics." So it's difficult to maybe extrapolate this to other areas, but this is kind of the study of biophysics, and since my background is in physics, I'm a little bit more
right.
Yeah, that you're getting the physics side of me.
I'm not demanding like an exact like numerical value for what medical fitness is. Like just a general sense of what you're conceiving of. I think I understand you. That's all I wanted to know. I didn't want to straw man you or anything.
No. I mean, there may be. I think it's actually, and this is going to be a little bit disconcerting. I think it's going to be on a case by case basis because every physical instrument has its optimal.
Yeah. That's fine. I get that.
Yeah, so the potassium channel is tuned to a certain way. A little deviation from it, it's going to fail.
But like a different medical system or a different biochemical system might, for instance, have much more wiggle room than the potassium ions. So you have to evaluate them each on their own.
The problem, there's two issues here, and we shouldn't debate this now. We can talk about this on Wednesday.
Yeah,
but the big
I did my best,
first,
Dapper Dino. So
no, I appreciate it. Thank you.
Sure.
I mean, the big problem first with this thing is what you just said, that there's no standard here. You can measure reproduction, and in terms of like, are you going to be alive as a species in a year or a century, in a millennium? Like, that's the measure that matters, because like muscles don't reproduce. You know, like my muscles aren't reproducing. They can work, they can not work, they can be strong, they can be weak. They're not the things that are propagating their alleles to the next generation. Depending on how you want to look at it, it's an organism or it's the individual alleles that are doing that work. The second thing, so you have so the level you look at matters in terms of what are you focusing on, and the thing to focus on is the actual propagation step. The other thing is looking at it like an engineering problem is cars, planes, precise machinery doesn't reproduce, and that holds inside a cell as well. The question is, can that cell reproduce? So, in the same way that a 747 or an A380 can fly with an engine down, a cell can operate with a mutation in one or in however many proteins it is. We all carry a bunch of mutations that probably change the structure of proteins in subtle ways in all of our cells. And like most of them work fine. We can tolerate that. And those cells are able to propagate just fine. So in terms of like actually assessing, viability over generations, which is what genetic entropy is about, that's not a relevant measure when it comes to being able to propagate yourself. The question is, where's that limit? And are populations inevitably going to blow past that limit and continue mutating?
If I can try to spitball like a dividing line that I think might be a stumbling block in your two's conversation. Forgive me if I'm wrong here. It seems like Dan is concerned with, like, if we have a 747, how many engines does it need before the thing is forced to ditch in the ocean. And
Or if it's a B-17, how many wings does it need? Because it's not two full wings.
Yeah, if the B, yeah, you're right. Those things are tough. But like, if we have a 747, it's got 4 engines normally. If it can fly with 2 engines just fine, then nature's going to try to keep it at an equilibrium around 2 engines at least. Maybe a little more, maybe a little more.
Well, I do want to quibble. It's not going to try, but if you get a variant that has 3 engines or 4 engines, and that subsequently experiences a mutation that then loses an engine, there won't be a fitness cost to that necessarily.
Right. But whereas Sal is coming from the mindset of, it doesn't really matter if the plane can make it to the emergency landing airport with 2 engines. The plane optimally would have all 4 working, and anything less than that is bad. I think that's kind of where there might be a little bit of talking past each other.
Well, that gets at the begging the question fallacy that's inherent to Sanford's argument.
I'd like to hear from Sal though.
Yeah, go ahead.
Yeah, I want to make sure he thinks I'm doing it accurately. First of all,
I think Corporal Anon is pretty close to my position. If you saw me a little distracted here, I'm actually trying to send you. I was looking through my library to get the Lewontin paper and the Grodwall paper, and I wanted to make sure that
I
actually
found the Lewontin one, which I posted here in the private chat.
Yeah, it's page 21. And
page 21.
Okay.
But
well, anyway, I'm going to send it to you, and so I just wanted you to know I wasn't trying to ignore you. I was actually trying to.
That's okay.
I forgot to include the subject.
If I get it.
So actually, I wanted to thank Dan, because it's when I made that comment, I actually started to get a lot of people writing and saying what you said was really interesting when I debated Ron Garrett about a week and a half before last night. I mean, people that were on the other side, I said, I never heard that before. Can you tell me more? I said, sure. I mean, this is stuff that has been, I found it interesting because Lewontin wasn't the only one that said there's a problem defining fitness. Andreas Wagner. And I'm just like, this is a very curious thing. And it all came to a head. Not that I'm answering anyone's question, but I'm just saying, I'm giving you my perspective. It all came to a head this past January and February when I was doing my work on Fisher's fundamental theorem. Really, most of it was just trying to write a tutorial, which I'm going to release because my contribution got cut out because it was considered to be it was too trivial. I'm just like, well, this is so nice. So it's actually going to be released publicly.
Fair enough.
It got cut out. It got cut out by my co-authors, John and Bill Basner. So you're going to actually get to see it on my website. So,
which is linked once again. Check it out.
Yeah. So it's not there yet. So I just wanted to thank Dan for his interest, because that's how come the debate. I mean, that's the way I interpret it. It's when I made that comment, Dan said, "Hey, I'm free next week. I want to talk about. Do you want to hash this out?" And I said,
and I'm really glad
to hear him say he wants to have a debate. I'm just like, sure. So that's kind of, it's very interesting. The very thing that that kind of sparked the debate was kind of almost the one that we got not so much discussion on.
Yeah, and I'm really hoping on Wednesday we can talk about that stuff, because it's not I don't think I'm mischaracterizing Sanford's argument in my intro last night. I was quoting pretty heavily from him in terms of how this works. So I definitely want to be able to dive into that on Wednesday. And like I said, I don't think I'm tipping my hand to say that, because I think that would have been obvious.
No, to be fair, one reason I'm doing this is we may be. I've encouraged. We're thinking about that book, and even the 2014 version. A lot of things change, and we get input from critics, and it's like, well, no, John, maybe we need to reframe this in light of all the things that, a lot can happen even in 6 years. And when they wrote the paper,
I would love to see a 2020 edition of Genetic Entropy come out, which takes all of what the critics have said into account. And if you want to reframe it in a completely different light that still gets the same message across, great. That's more discussion. It's a more accurate view.
Yeah. And what I told John, because when he gave his NIH lecture talk, and I'm going to point out something, at the 2018, first of all, this is a chance to set the record straight. there's kind of a rumor that we rented a room. That's not true at all. We got invited by someone on the NIH staff, and the government paid for the audio visual and the room. So that was an official invitation, although the individuals involved did get reprisals. So Dr. Sanford won't be invited back. That's not surprising. But afterward, I talked to John. I said, there are just a couple of things that are in my area of expertise, which is information theory and thermodynamics. I said, if you come out with the 5th edition, it's already in its 4th. I said, can I rewrite some parts? It might be only a paragraph here or there, because I think you're going to get dinged on this. I can't defend your work if you say stuff like this. And one of them was on thermodynamics and information theory. So when Ron Garrett debated me, I kind of blindsided him. I said, actually, I agree with you. This is something that needs to be rewritten, and I've recommended it be put in the 5th edition, but I don't think that this in any way destroys the fundamental thesis.
Well, wait, so if you don't mind, what specific part of the older editions do you disagree with?
The one on the description of information, and it's tied to thermodynamics and the second law, because that was my graduate work.
Thermodynamic stability?
I'm sorry, I don't have the page, the chapter and verse handy right now.
I have a highlighted version, but I don't have it in front of me and ability to search through it at the moment. But yeah,
so
I was just curious because I don't know that would change the overall message if you were to reframe that part in terms of structural biology and that kind of thing, and structural precision, however you want to frame it. I don't think that's going to change the overall gist of it. I don't think that addresses the underlying problem with the genetics, but I'd still be really thrilled to read a new edition and be able to talk about that.
We'll send it to you complimentary. We won't charge you.
Oh, okay.
That's kind.
Hey, free books are always good. So actually,
but I mean, the thing is, I wanted to at least say, let's avoid kind of what we call in tennis unforced errors. It's not that we can correct. We're going to have enough problem defending the hypothesis, and let's just not make mistakes on our own. And that was
Avoid
really hard
making errors which aren't part of your main hypothesis.
Yeah, but I wanted, that was really difficult because to criticize someone that I admire and respect, and I felt my head was on the line to say, Doc, you're this page here is not quite right.
I've had to do the same things with Kevin Henke and his criticisms of some creationist geology. I've had to say, like, hey, I used to be a young Earth creationist, and they don't really say what you're saying here. Maybe you should fix this. And what I love isn't the struggle of having to tell someone you admire, hey, you need to fix this. It's when they say, hey, thank you for making my case better. That feels really nice. And that's nice. That's a good experience.
I mean, I think one thing that this whole thing about fitness, I said, John, I'm really unhappy with the definition of fitness, and it's just, I think it's making it very hard for me to defend your argument if we keep using the evolutionary definition. So maybe that's a very succinct way of answering Dapper Dino's question.
Okay, but it also makes.
Can I follow up on that though?
Well, I want to get my quick thought out because
then
we'll. The thing that concerns me about that is that you're saying, in this attempt to kind of revolutionize the entire idea of evolutionary biology, we cannot defend our idea unless we talk about something about not evolutionary biology. We have to go outside of evolutionary biology's definitions.
If I can just warn you, because I know, Sal, you're a bit conservative leaning like me. I'm sure you're annoyed if people say, like, look, it's unfair unless you let me define the terms, like with politics. I'm just going to warn you to be careful with how you present your argument on genetics, to not come off the same way. Because that can really deter people from considering what you're saying if you seem too blatant about, like, look, if you don't let me set the terms of this debate, it's unfair.
Right.
Yeah.
Oh, no, I mean, thank you for putting that out there, but I'm just speaking as an engineer. All right.
Okay.
So,
yeah.
Okay, that's fair.
In terms of physics, I'm just saying this this always sort of grated. It sort of grated against my understanding of machines, and then the fact that people like Andreas Wagner, who I think is a good evolutionary biologist, as far as I know, and definitely Lewontin, I said that they're kind of seeing that they were having a hard time defining fitness. I said, okay, so I'm not the only one that is having issues with this, and it's not just because I'm a creationist. There are evolutionary biologists that have had problems with this. So maybe this is a discussion that needs to happen, and not that I have a resolution to it, but
let's go
maybe
back to Dan for a bit. I think.
Sorry?
Yeah, I mean, it's. I hear where you're coming from, in that it's what this boils down to is that it's difficult, bordering on not feasible, to make the argument that Dr. Sanford is making if fitness is defined as relative reproductive success. The problem is that is the definition of fitness in evolutionary biology. You could talk about fitness in an engineering sense, in a medical sense, whatever, but like you're talking about things that are going to make people look at your argument sideways, or kind of question the credibility of the underlying argument. As an evolutionary biologist, if someone comes to me with an argument that requires the redefinition of like a fundamental concept in the field in which you're making the argument, that is going to discredit the argument off the bat. And that's why people don't take it seriously, because people like geneticists and evolutionary biologists read Sanford's book and they just shake their head because it does not comport with the state of the field and the way that words are used in the field. And I would respectfully suggest that is a larger problem than the intricacies of how you want to redefine fitness. The underlying problem is wanting to define fitness, or maybe I should say needing to define fitness, as something other than how the word is defined in the field of evolutionary biology. That's like the fundamental problem.
Well, no, I appreciate the input. I got a. Oh, that wasn't addressed to me. Couple of said, Dan, can I get your email? Sorry.
Yeah, I want to forward the papers that you sent.
I'll get you after. Yeah.
Okay.
Thanks, man.
So one thing that I notice a lot, and it seems to come up a lot when, and this isn't to be disparaging, but it happens a lot.
Sorry, guys. I got to get out of here. I got some
right.
friends downstairs that I need to go.
All right. See you later.
Good night, guys. I love you all. You're
Thank
great.
you.
Bye-bye.
Nice seeing you again.
So, no, I'm not trying to disparage anyone here, but a lot of times when I see engineers step into areas around evolutionary biology, they have this strongly teleological bent towards the way that they approach biology, which is understandable. As an engineer, everything you do is teleological. I need to design a thing to do this job that needs to be done. And so it's very goal-oriented with a purpose in mind, but until you can actually demonstrate that there's teleological design in life, I don't see why using teleological definitions...
Hang on, commercial break.
Oh, no worries.
All good. If you want to, we can take a couple minutes here, and I could go back to the H1N1 thing.
Oh yeah, sure. Go.
Would people like that?
I think people really would. People really were enjoying that.
We did the colon bias part.
I want to go on this Lewontin thing because I've read through that fitness section really quick.
Oh, I think Sal's back.
Problem. Quick.
Hey, welcome
Sorry
back.
about that. My mother's a fault.
Hey,
so
it's 100% okay. No one here is going to fault you for taking care of your family, man. That is that is priority one around here.
If I cut off my camera in a little bit, you'll know I'm taking. But I'll rejoin you. I'm not going to leave you all without saying goodbye.
It's all good. So Sal, what we were talking about right when you joined was actually that the H1N1 paper, and we're going through. I was going through why the measures of fitness in there did not measure up, and it gets at this idea of what we were just talking about of this and Dapper, it's kind of what you were talking about of the teleological idea of fitness, and using virulence as a measure of fitness in that regard for a virus makes sense, but from an evolutionary perspective it doesn't, because it could facilitate reproductive success, but it could also, as Colton described earlier, it could also hinder reproductive success depending on the specific transmission mode and the specific ecological conditions. And if you all don't mind, if I can just pull up that slide one more time.
Absolutely.
Just to kind of go back to that briefly. If I could find it here, I don't think I have as many slides as Sal had prepared for last night, but I made a bunch. Here's the one I was looking for. Here it is. Let me just go to this one and back to this. Here we go. Sorry, this will just take a second.
No worries.
There we go. Eventually, I'm going to get like fast at this, but right now this takes a couple seconds. Okay, allow. Okay,
commercial break. I'm sorry.
PowerPoint.
No worries.
All good, Sal. So here's the problem with fitness, and this gets for everyone that was here a little while ago when Colton talked about this. Colton did a great job of describing kind of phenotypically what's going on. If nobody minds, would it annoy people to like nerd out a little bit into like the underlying selection dynamics here, because the why rather than the what?
Dan, I'm going to tell you
dynamics, because it is endlessly fascinating to me, but if it's not to other people, then I can skip it.
I can't speak for other channels, but if you're on this channel and there's people watching, chances are they want you to go into as much crazy technical detail as you can.
You have given me the blank check, and what happens from here on, I do not apologize for.
Hey, that's why people come here. They come here for crazy technical stuff.
So here's the deal. Let's consider this from the perspective of the virus. What's going to work best for you? Early in a pandemic, right? New virus, new strain. Nobody has immunity to this strain of the virus, except for that one. There was a cohort from the 1880s, but we're not going to worry about that. So you have an entire population that's susceptible. So it's really easy to go from person to person because everybody is an option to infect. The thing that's going to limit your ability to spread is competition within each host. That's called intra-host competition. Okay. So viruses within an individual person are competing with each other to infect the cells of that host. This is when everybody is susceptible. The limiting resource is cells within a host. Under those conditions, the optimal strategy for a virus is to reproduce as fast as possible and be the largest possible fraction of the viral load in that host. And it doesn't matter if you kill your host really fast, because everybody you're exposed to is a potential host.
Right.
So as long as you're exposed to somebody, you're going to jump into the next host. So the limiting step is within host competition, and that means you have selection for very high virulence, right? You make your host very sick.
Mm-hmm.
Now, after the pandemic goes through, like a really bad pandemic like 1918, now a bunch of the population, an extremely large fraction, I don't know what fraction got that virus, 5, 10, 15, 25, I couldn't tell you off the top of my head, but it was enough to change the dynamics of that virus to where the limiting factor, rather than competition for cells within a host, the problem becomes being able to find an additional host in your population of hosts. That's called intra-host competition, inter-host competition. Right. And under those conditions, the viruses in me are not competing with each other. They're competing with the viruses in other infected people to get to the next susceptible person, because there aren't that many susceptible people left relative to the beginning of the pandemic. So late in the pandemic, when you have few hosts, the competition is between viruses in different people. And under those conditions, if you're highly virulent, if you kill your host fast, you're not going to find another susceptible host before that happens. So your fitness is going to ultimately be 0, even if you make up, you being your strain, your genotype, makes up 100% of the viral load within an individual person. So under those conditions, you have selection for low virulence. Yeah, you get a cold, you get the sniffles, but like Colton said, you're out and about, you're touching stuff, you're shaking hands, you're infecting people.
Right.
And that's the optimal phenotype late in a pandemic.
Right. And
this is kind of theoretical, but there's like an experiment for this. This is Heinemann and Bull, 2007, did this with bacteriophages, growing them in high and low host density environments, where under the high density environments, they evolved a very high doubling time. This is doublings per hour. So they evolved a very high doubling time with a relatively narrow range. In the viruses in the low density host environment, The optimal strategy there was hang out in your host and grow slowly and just churn out a bunch of you, but do it slowly and don't kill your host. So you end up with a much broader distribution across the time it would take you to reproduce, and you're growing much slower because you don't want to give up that host. You might not find another one. So you need to maximize your ability to get every little bit of reproductive output you can from that single host. So the fitness or the virulence changes that Carter and Sanford describe in their paper, the drop off in fitness from very dangerous fall of 1918 through the 20th century until it was by 2009 not at all a very dangerous virus. That strain was actually less dangerous than your average flu strain. Those fitness changes are adaptive. That's helping that virus spread in not a naive population that's never seen it before, but a population that's been infected by it in waves for decades and decades. So what they claim is a reduction in fitness is actually an increase in fitness. It's selection for just a different virulence phenotype.
Yeah, it's
that's
almost
why that
like
measure is wrong.
It's almost like in different environments, different things give different amounts of advantage.
Amazing, right? That
Yeah.
there's this thing where context matters for the fitness effects of genotypes. Yes, that's exactly it. And by the way, thank you everybody if you didn't fall asleep during that spiel. I appreciate it.
I think that people quite enjoyed that. Like I said,
enjoyed it.
It's the people who subscribe and show up for my live streams are usually people who really like to hear someone who really knows what they're talking about digging into the details of the science. I think that's where my sort of niche is in terms of who wants to come onto the Dapper Dino channel to hang out in the chat. But actually,
would you say that trait is high fitness in this environment?
In this environment, wait,
But
being nerdy?
but not in other environments. I was trying to make a joke, but I'm bad at this. I don't know.
Being nerdy is actually, interestingly enough, I think that being nerdy is becoming. It's for a long time. It's been a very, very much non-adaptive trait. I think that's starting to change, though.
So can we do one more problem with the H1N1 paper, because this one's my favorite.
Absolutely.
I love this one. So the linchpin of this whole thing is that the H1N1 went extinct. The problem is that it didn't. And in the paper, Carter and Sanford, I think accidentally acknowledged that. I don't think they meant to. But if you read the paper carefully, they actually treat H1N1 as though it did not go extinct. So what they say is that you have this lineage descended from the 1918 pandemic strain. And you get to 2009 and you have this reassortment that occurs with a few different strains of swine and avian flu. And then the 2009 pandemic strain was kind of the final nail in the coffin for the pre-recombinant strain, the reassorted strain that was the descendant from the 1918 pandemic. So one lineage of H1N1 replaces the older lineage of H1N1. That's what they claim happens. But they also say this. Similarly, there was a continuous and rapid accumulation of mutations over the entire history of the virus, and then cite their own figures 2 and 3. And I want to emphasize over the entire history of the virus, which I think a fair reading of that is treating it as a single lineage. The figure that they reference there, figure 2, includes sequences in the red circle, which I did not add. That's in the original.
Okay.
Include sequences from 2012. So they, in tallying up the mutation accumulation in this lineage, they blow straight through the supposed extinction event and tally up mutations for 3 years afterwards. That's acknowledging that the lineage didn't go extinct.
Otherwise, how would you have gotten post-2009
Otherwise, you
data?
can't count the mutations. It's
Right.
a different lineage.
Yeah, that's a weird thing. I'd like to give them benefit of the doubt and say maybe they just mixed up which year was which on when they were saying when it was supposed to go extinct. I don't know. I haven't read it.
I mean that bit of the H1N1 descended from the 2009 pandemic is still around.
Yeah.
And it reassorted. It's when you get co-infection between more than one strain and the genome segments, you get like mixing and matching in the new virus. And there was part of the genome from the pre-2009 strain was in the reassorted 2009 strain. So it's not the full genome persisting onwards, but part of that genome is persisting.
Well, and the thing is, a full genome is generally not going to persist anyway, because once it mutates, it's no longer the previous genome. So
That's an excellent question. And is it fair to call it the pre-2009 pandemic, so the old H1N1 from 2009, pre-pandemic, is it fair to call that strain the 1918 strain? No, it's a completely different genotype. I think it's fair to call it the lineage. But
Right.
calling it the pandemic strain is wrong. It's not the pandemic strain.
there's a
It's different
continuity,
virus.
but it's definitely not causing the same kinds of things.
That's a great way to say it, yeah.
And actually, so my degree is actually in history, and one of the things that we talk a lot about in that is to what degree there is continuity in different historical events, and I think it ties in nicely with biology too, where it's like, can we say that, say, like, did the dinosaurs go extinct? It's like, well, every species that was alive 66 million years ago is currently either extinct or its modern descendants are significantly different. So would an animal from that time be recognizable to us now? Only vaguely. But did they go extinct? Well, kind of yes and kind of no. It depends on how you want to look at things like the continuity.
Well, so this is a great point, and it gets at something that where I'm definitely out on a limb in terms of evolutionary biologists, but it's for this exact reason that I don't think the concept of a species is actually useful. I think talking about lineages is useful, and if you define a species as a lineage, I think that works. Now, horizontal gene transfer messes with it, but defining it as a putting things in a box that goes back some amount in time where that time is not always clear, I don't think that helps us with our understanding of things. So like I'm not well versed enough in like biodiversity, historical biodiversity, but like the concept of living fossils. Like, would a coelacanth from the 21st century recognize a coelacanth from however many million years ago as a potential mate? I mean, probably not, but that's an unbroken
based on the
lineage
fossils
that had
that we
very
have.
similar morphology.
The fossils we have for the coelacanth group actually are pretty different from modern coelacanths. Now, one of the problems there is that because of preservation bias, coelacanth fossils are almost all from shallow marine or like freshwater environments. And it's an open question as to how far back this deep ocean group diverged, because we don't have any genetic data that we could use to try and determine that, or any morphological data, because if they did that early on, we would lose their fossils almost immediately. So it's tricky, but the thing is, you can look even at more recent things. Like, you can look at, say, just look at humans, right? Like, we have a pretty good idea that Homo sapiens probably evolved from Homo erectus population, or a population that would have been identified as Homo erectus.
Heidelbergensis, maybe?
Right, but they themselves are almost certainly a descendant population from a more broad Homo erectus.
Right.
So if you look at a Homo erectus reconstruction, that's a fairly reasonable one, you can see why it seems human, but most people probably would not find themselves entirely enticed in terms of reproduction with this individual. They're not quite close enough that it triggers our, oh yeah, that's someone that I could see raising a family with. And so
this is fascinating, and I could literally talk about this like for hours on end, because this is what I do for a living, and like I just get paid to talk to people, and I would be saying things and probably annoying people talking about biology anyway. But we should probably bring this back to the context of the debate, since this is the post game for the debate.
Well, speaking of the debate, one of the things I would really like to see is an unambiguous example of an error catastrophe in an actual group of organisms.
Yes.
And basically, that there are so many organisms out there that are currently alive and reproducing at extremely rapid rates, but we don't actually have a single plausible candidate, makes me think that, I mean, there really isn't much to this.
You can point to examples, and some creationists will point to examples of extinction vortex, and we could go in, if anybody wants to, we go into what that is. But as an example of genetic entropy, because even Sanford describes it. Thank you. Sanford actually describes this as basically saying, okay, you're gonna mutation until right at the cusp, and then all of a sudden diversity collapses and you go into what's called an extinction vortex, which is when you have very low genetic diversity. And that leads to a lot of inbreeding depression. So you have a lot of homozygous recessive harmful traits accumulate. And this is a positive feedback loop where you have genetic drift and lots of homozygosity that causes inbreeding problems, genetic conditions accumulate, the next generation is worse, and that amplifies the problems, and over time the population loses viability. And this is like, for example, why bottlenecks are so dangerous, because if you just happen to get a few homozygous recessive individuals for, say, hypothetically bad hips in a species that relies on running really fast to catch its prey, then that could potentially down the road result in major problems for that species as a whole. So what Sanford kind of describes, even though it's not really, it's not, he doesn't go into, it's almost like a side note, but he describes like, okay, mutations go up, and everyone's going to die, except right at the end, it collapses in an extinction vortex. Now, the problem with that is error catastrophe and extinction vortex are opposite things genetically. An extinction vortex is the collapse of genetic diversity within a population, and error catastrophe is extinction due to the accumulation of too many mutations that break genes. You're greatly increasing the allelic diversity of a population, and most of those new alleles are not functional. So it's a little ambiguous there what the actual end game process is supposed to be in terms of like going from lots of mutations to dead. Is it the mutations that do it, or do they get you 90% of the way there and then drift and like inbreeding depression do the rest? And not even Sanford is actually clear on that. So,
yeah, and also, it seems to me like we would expect, if this were the case, for there to be periodic extinction events, especially in quickly reproducing organisms. Like, it seems like there should just be like, oh, every, few hundred years, nearly all of the mice species just kind of go extinct?
there is actually a test of this, and it goes back to something Sal brought up last night. And so he was talking about Muller's limit, which isn't actually a thing, but the concept is Muller's ratchet.
Yeah, I was familiar with Muller's ratchet.
Yeah, so it's this idea that in a haploid asexual population, mutations are just going to accumulate because you have no way to uncouple the beneficial alleles that you find through mutation from the harmful ones. So you get a hitchhiking effect where if you select for beneficial allele A, you're stuck with all harmful alleles B, C, D, E, F, and G in that same linkage group. You can't get rid of them. Now,
because at that point, the whole genome is basically a linkage group.
Exactly. So that is fixed by two things. One is recombination, and two is having genomes that have a low functional density, like the human genome, which something along the lines of 10 to 12% functional, and approximately the same sequence. It's sequence constrained is weird in terms of functionality, but it's those mutations in non-functional regions, and you get recombination, so you can uncouple the useful ones from the bad ones. Yeah. Now, we actually do have a natural experiment for this in the case of asexuals that pop up, and this happens in natural populations where asexuals will repeatedly pop up. And it's a nice test of the theory. Is Muller's ratchet a problem? And the answer is yes, but only in asexuals, because what happens is you get a short-term benefit from being asexual. You can reproduce faster because you don't have to find a mate. You don't have to worry about search cost and genome dilution and everything. You can reproduce faster. You get more bang for your buck.
That's happening here with crayfish right now.
But what happens is you end up with too many harmful mutations because you can't do recombination to get rid of them. So selection has fewer tools to work with. So in species where you evolve asexuality, it typically loses out. And in the species where it hasn't, like Deloid rotifers, they have other mechanisms to do that same thing. Like these rotifers have a tetraploid genome, and they actually do recombination. And it's not technically tetraploid; it's two diploid sets. And they recombine between the sets to simulate sexual reproduction, even though they don't actually exchange gametes. So the species that persist in an asexual state have other workarounds to solve that problem, which shows, one, that it is a valid problem, but two, there are solutions to it, and most species have found those, like sexual species have found those solutions. The species that would be susceptible to that problem have found the solution to that problem. So, like, yeah, that's what's going on there.
So good news for Europe is that those crayfish that are overrunning all your ponds, they're probably going to be gone eventually.
Yeah, no, really, that's a legit prediction to make. Yeah.
Or even worse, they actually managed to make a way to get around that issue.
It seems unlikely, but it's possible.
It's possible, but also consider that the workarounds carry some of the costs of sex, because now reproduction is more complex, it takes more energy. You don't have to find a mate, but you still have to do meiosis, essentially. So it's still, you get the benefits, but it's not for free. You still get some of the costs associated with it.
Yeah.
Welcome
Welcome
Sal.
back, Sal. Hey, by the way, I figured out the
I don't think his
hack over here of
earbuds
having
are
the
in.
chat open while we were chatting, and I saw someone say Wikipedia claims error catastrophe has been observed empirically. If you want to check the sources on that, I would love to talk about it, because I got a whole list, and none of them have, unless there's something very recent that potentially I've missed. But I got a whole list, and none of them do it for very specific reasons. And in particular, I'll warn you against Crotty 2001 using ribavirin. I think it was a polio virus. No, that one's got problems. But I'm happy to talk about why if anyone wants to talk about that one or any other ones.
Well, I don't think we have
that's
a
totally related.
huge amount of extra time, unfortunately. Normally I can get these to 2 hours, but today it's not as much of an option as it normally is. So
that's okay.
I think what we might do is, Sal, can you hear us? I noticed you didn't have
Yes,
your earbud in.
I'm
Yeah,
back
okay.
online.
Awesome.
Thanks, guys.
So I think what I'm going to do is give some quick wrap up, and if people have anything that they want to plug, and then I'll give some quick channel news for what to expect in the coming days, whatever.
Can I quickly go over this paper? Really quick?
How quick is quick?
Very quick. I just want to make a note.
I was hoping for a number, but like numbers and units.
A few minutes.
A few minutes? Okay, I'm going to set a timer. You have 3 minutes starting when I hit the start button, which isn't now, so you better hurry up.
Nice. On Lewontin's thing from 2003, I'm looking at this, and he doesn't seem to so much have an issue with reproduction as definition of fitness as he does with a gradualism position on it. This is very much made from a punctuated equilibrium position of, a animal can affect its environment much like the environment can affect the animal and how it survives. That seems to be his major gripe with Darwin, how Darwin viewed fitness. Not so much redefining it outside of reproduction.
I mean, it certainly is true that animals can, in some cases, dramatically affect their environment. I mean, just look at humans. Humans survive essentially by creating artificial bubbles of habitable environment wherever they happen to be. Like, if you look at, this will be a quick thing on my part because now I'm the one going on. Like, say, take a look at where humans almost certainly originated, right? It's basically Eastern Central Africa, the Rift Valley. If you're a reasonably healthy adult human who knows what things you can and can't eat and, has some outdoorsy skills, you can be dropped into that environment naked and you'll probably do okay for about 10 years or so without any real big problems. But then you look at some places that humans have gone, like, above the Arctic Circle. You would be dead in minutes if I did the same thing. If I just dropped in a healthy adult human naked above the Arctic Circle, you would be dead in minutes. Literally, it would be about 10 minutes or so before you died. Or were no longer recoverable. You might linger on for a little while, but you're not coming back at that point after about 10 minutes of exposure to the Arctic winter. But humans, we would just say, we'll just take our environment with us. We'll build houses, we'll make fires, and we'll take fur from other animals and use it for ourselves. So yeah, that is definitely that point that you can't just say that the environment is this thing that is imposed from the outside on all organisms. Organisms do impact the environment in which they exist. But,
another good example would be animals that spread seeds.
Yeah.
Those actively impact the environment.
Yeah, but I think that is probably where we're gonna leave off the sciencey discussion. And TD Lane, do you have anything you want to plug?
At the moment, no, as I still working on my video.
Okay.
School is slowing me down, but today I finished all my teacher grade assignments for my class I had to work on, so yay.
Congratulations. All right, Sal, do you have anything that you want to plug?
Oh, the debate on Wednesday, and I'd like to just I'll plug Dan. I appreciate he's probably done more to get me attention on the net, and there's a saying it's better to be criticized than ignored, and
Fair enough.
he's helped me to that effect. So, and I'll plug your channel. How can I plug your channel?
Oh, I mean, if you want to just so there will probably be another after show either Wednesday or Thursday, depending on what time is the debate again? Is it 8 p.m. Eastern?
8 p.m. this time.
So yeah, we probably can't do another a same day one. So we can probably do a next
Day after is good. Yeah.
Okay. So yeah, if you want to just on the debate, you can just say that, hey, the next day there'll be a after show, and there you go. And if you want, you can ask James to put a link in the channel or in his description to my channel, so people can know where to look for that. But thank you. I really appreciate that. That's extremely generous of you. And Dan, what do you got?
Hey, so as of right now, I don't have anything to plug, but I will have a YouTube channel on this topic coming soon. There's nothing there right now, but it's called Creation Myths, and let me tell you, the production values are not going to be this, but I'm going to do
that like I have crazy good production values.
It's going to be short videos, one take. You're talking 5 to 10 minutes on a very specific topic. So, for example, if y'all want to hear me talk about Carter and Sanford 2012, I'm going to do one. I'm going to do one on that. And very, very specific, very bite-sized little things on creationist science, very specifically science.
Okay.
So it's going to be going to be called Creation Myths, and you can find me at creationmythschannel@gmail.com if you have any ideas or anything, and I will have a link to that available by Wednesday, and then if we want to retroactively put it in this description, that would be cool.
Absolutely.
But whatever. But it's nothing yet, but it will be. It'll be something.
Okay, awesome. Well, that comes to first I want to say Sal's website is in the description. If you haven't gone and checked it out, maybe because you've been here the whole time or something, give it a look. If you don't see it, it probably just means that you have to refresh this page. But as far as channel news goes, let's see. I have recently been invited to be a guest panelist on the Strikeling's movie night tonight, so it looks like I'm going to be there. I don't have a link, but go check that out. Those are fun. Let's see.
Well, I actually have to go ask Cy Strickling if I can come on tonight and maybe next weekend.
Well, there you
next
go.
Friday.
Let's see. There's nothing going on Saturday. I know normally I have something on Saturday, either an upload or a stream or something, but Saturday, nope. Because Sunday, starting at 10 Pacific, 1 p.m. Eastern, so that's 10 a.m. Pacific. Yeah. There's going to be the start of the birthday streams, because I'm celebrating my birthday with my audience. I've already told my family, hey, I'm going to give you a call early in the day. Maybe I'll call between some streams, but we're going to do 6 hours or so of streaming over the course of 7 hours total. First up is going to be Corporal Anon and I talking about Andrew Snelling. So, yep, Dan knows who Andrew Snelling. So Corporal Anon and I are going to talk about Andrew Snelling for a few hours. Then I'm going to go do some just having fun, playing some video games on air with you guys. And then we're going to delve into some more biology stuff for the final 2 hours. So look for a 10 a.m. Pacific to noon, then a noon 30 to 2:30, then a 3 to 5 stream from me. And those are all Pacific times because technically I'm in Mountain, but Arizona doesn't change their clock. So right now it's the same time here as it is in California. So there you go. Then Tuesday will almost certainly be the next Kent with Bent. There's a slight chance it will be Eric with Erica with Guts at Gibbon, but probably not. Then I'm not sure what's going to come out that next Thursday, a week from now. It's either going to be a challenge video where I have 5 challenges for Kent Hovind or his fans. 5 questions to answer. see if I get any actual responses. That's either going to be that, or it's going to be the next episode of the Fluffy Dino Lads, where I'm looking at In His Image and his attempts to debunk the idea of feathered dinosaurs as a thing. So there you go. That is it for channel news.
I will put the movie night into the chat really quick.
Oh yes, yeah, put movie night into the chat. So if you want to go check out Sci Striking's channel, it's not for a little while. I think it's still not for another hour or so. But yeah, that's it for me. So thank you very much, Sal, for coming. Thank you very much, Dan. Thanks, TD Lane. Thanks to Corporal Anon and RJ and Dakota. Man, there was a lot of people on here today. I'm trying to think, did I miss anyone? I don't think so. So hopefully I didn't miss anyone.
You got it, buddy.
Okay, good. So thank you very much. And everyone who came into the chat, I appreciate you guys. And yeah, tune in next week for the next debate between Sal and Dan. I'm sure it will be pretty good. So, all right, bye, everybody.